So far, I've been sharing information with you about biomes or terrestrial land ecosystems that are governed by the climate, the precipitation, and the temperature of a region. Now we're going to shift gears and talk about aquatic life zones or water biomes. We call water biomes aquatic life zones and provide a different terminology for this to separate it out from land and terrestrial biomes. There are marine life zones located in waters that are predominantly saltwater or a mixture of saltwater and freshwater. These marine life zones occur in our oceans, estuaries, coastal wetlands, and also coral reefs. Oceans actually comprise 71% of the Earth's surface and hold 98% of the Earth's water, so it's definitely an important area to look at for more detail. The aquatic life zones have distinct environmental and characteristic plant and animal life adapted to sunlight and nutrient conditions. The food chains in the aquatic life zones begin with producers, known as phytoplankton, which are consumed by zooplankton and eventually fish. Another category of aquatic life zone is the freshwater life zones, and this is referring to any lakes, rivers, streams, and wetlands. Freshwater life zones can be standing water, also known as lentic or Lentic, such as ponds and lakes, or flowing water, known as lotic, Lotic. These bodies of water only cover about 1% of the Earth's surface, but yet contain more than 41% of our world's known fish species. So, very important to protect our freshwater aquatic life zones since they represent such a small percentage of our Earth's surface, yet contain a large majority, 41%, of our world's known fish species. Most aquatic life zones are divided into surface, middle, and bottom layers, and I'll show you some examples of that in the next couple of slides. The environmental factors that determine the number and types of organisms that are found in these different layers are temperature, access to sunlight for photosynthesis, dissolved oxygen, and availability of nutrients, such as carbon, nitrogen, and phosphorus for the producers. Food availability can also impact this as well. This figure depicts marine systems that provide important ecosystem and economic services. As you look at the list under ecosystem services, the marine ecosystems provide oxygen through photosynthesis. They can provide water purification, climate moderation. We know that our marine oceans absorb carbon dioxide as part of the carbon cycle. In addition, the marine ecosystems can help do nutrient cycling and can impact the coastlines by reducing storm drainage if there are mangroves and barrier islands as well as coastal wetlands present. And last but not least, they provide the opportunity for a variety of habitats which enrich the biodiversity of our marine environments. As far as economic services, if you've had any kind of seafood, you rely on our marine ecosystems for food. In addition, we can harvest energy from waves and tides. Because of the great vastness of biodiversity in our marine ecosystems, we have learned that we can harvest some of that to create pharmaceutical drugs. In addition, we rely on our marine ecosystems for transportation routes, recreation and tourism, as well as the extraction of mineral resources. This figure depicts the major life and vertical zones in an ocean. The actual depths may vary, but let's look at the three major marine life zones. The first one is the coastal zone region. This can consist of estuaries, which is an area that is a mixture of freshwater and saltwater, or coastal wetlands. Warm, nutrient-rich, shallow water comprises this type of marine life zone. It extends from a high tide mark on land to the edge of the continental shelf. Now, coastal zones make up less than 10% of the world's ocean area, yet these zones are the regions that contain 90% of all marine species, and it's the site of the most largest commercial marine fisheries. This zone also has a high net primary productivity due to the ample sunlight that's available and the plant nutrients that flow into the ocean from the adjacent land. The next major marine life zone is the open ocean. The open ocean occurs beyond the edge of the continental shelf and is divided into 3 vertical zones, largely based on the penetration of sunlight. On the y-axis over here, we have depth in meters, so it's depicting that at about 200 meters is where photosynthesis ceases to occur. And then from 200 meters to 1500 meters, we call this a twilight zone, where there's just barely light getting through. And then deeper than 1500 meters is considered to be complete darkness. The 3 zones are actually named the euphotic zone, the bathal zone, and the abyssal zone. The euphotic zone, because of photosynthesis being present in this region with sunlight, is where drifting phytoplankton actually carry about 40% of the world's photosynthetic activity. The bathal zone, or the middle zone, gets little sunlight and therefore doesn't contain photosynthesizing producers. And then the abyssal zone is very dark and cold, and it has very little dissolved oxygen down in this region. Which brings me to this section of the diagram depicting temperature, where this end is colder and this end is slightly warmer in degrees Celsius. So in the abyssal zone, we're dealing with a very slight increase in water temperature, but this is cold in the abyssal zone. And then we transition through the bathal zone, and we're getting warmer between 25 degrees and 5 degrees Celsius. And then the temperature increases more in the euphotic zone, up to about 28 degrees Celsius. So water temperature can drop rapidly from this euphotic zone down to the abyssal zone, and this intermediate area where the temperature does do the decline is called the thermocline. And it's right here on the slide if you want to know how to spell that. So, why is protection of marine biodiversity so difficult? Well, we do have our human ecological footprint expanding, and we rely heavily on our marine ecosystems as a source of food. And you will be watching some videos that describe overfishing and the impact of not sustainably harvesting fish from our oceans. The other reason is that it's not visible to most people, and as a result, it's not thought of often, and it's forgotten. In addition, the ocean and marine environments are viewed as an inexhaustible resource because they cover so much land area, or so much area of the Earth's surface. And finally, I think this is one of the reasons where it's really difficult to protect marine biodiversity, is because most ocean areas are outside the jurisdiction of a country, and therefore we lack the ability to enforce the protection measures that we want to put in place to protect species of concern. This diagram depicts major commercial methods used to harvest various marine species, and these methods have become so effective that many fish species have become commercially extinct, meaning that they might be available in the waters, but their populations are so low in number that we shouldn't be commercially fishing them. So I'm going to click on a few of these to give you the names of what they are. So when we do commercial fishing, we can do fish farming in a cage off the coastline. There are some issues associated with this, with excessive nutrients getting into the water and causing eutrophication. We can use sonar to figure out where the fish are located in order to harvest them. This is purse seine fishing with a large net. We can do long line fishing, but this is not yielding as large of a harvest as compared to other techniques. But there is concern as well that this technique can cause problems with impacting species. We have a deep sea aquaculture cage approach that's being used, where we're actually fish farming out in the further distance in the ocean away from the coastlines. We have drift net fishing as well. And we jumped into the next slide. So those were examples of different types of fishing that are used. So some solutions for marine ecosystems include, let's protect our threatened and endangered species, and in international waters figure out a way that we can accomplish this through collaborative effort between various countries. Also, let's establish protected marine sanctuaries and create these areas where fishing's not permitted, dredging's not permitted. Any activity that disrupts the environment of the marine area is not permitted. And then you have marine reserves. These are easy to implement and work well. And then do integrated coastal management between countries and protect existing coastal wetlands. This next slide gives more detail on how we can protect our fisheries. Implementing good fish regulations, which can set catch limits that limit the amount of fish that can be removed to be well below the maximum sustainable yield, and this would allow the fish to reproduce and keep their population numbers at a stable value. We can improve monitoring and the enforcement of marine law and protective measures that are being set into place. In addition, there are some economic approaches where we can eliminate fishing subsidies or charge fees for harvesting fish and shellfish from publicly owned offshore waters, and certify sustainable fisheries. And we're starting to see this in our grocery stores, where the packages on our seafood depict how those species were harvested, whether they were harvested sustainably or not. Set up more protected areas that define no fishing areas, as well as work together with other countries on integrated coastal management. And then set up some good labeling on products that get into the consumer's hand that indicate whether something is sustainably harvested or not. And then in terms of bycatch, use wide mesh nets to allow escape of smaller fish and decrease the amount of fish that are being impacted by bycatch. When you use nets and you bring fish up and they're too small, you have to throw them back in the water, but they may have already been stressed and impacted by the net and still end up dying. So this helps deplete the younger fish population that we have. Use net escape devices for seabirds and sea turtles, and ban throwing edible, marketable fish back into the ocean. So when it comes to aquaculture, it's a good approach in order to benefit less depletion of marine fish species in the oceans. However, there are some control issues regarding pollution that stems from aquaculture. So the goal is to restrict coastal locations for fish farms so that we're not impacting that near coastal area with too much nutrients and resulting in eutrophication, which then depletes the oxygen from the water, which can obviously impact the natural marine environment. And then also work in a way to limit non-native species getting moved around the world to different areas that they shouldn't be. So you're going to learn about the lionfish, for example, and the crown of thorns starfish. These are both considered invasive species that are having detrimental impact on the environment and marine ecosystems. This is just a list of